So in this video we'll be talking about Rust ownership, references and borrowing. So let's go and declare two variables. Let a is equals to 6, let b is equals to 10. Let's go and print these values. And we can see the value 6, 10. Now let me change this 10 to a. Now obviously in other programming languages the value will be copied. That is also same in the case with Rust, but only with these normal data types, not with the vectors and strings. These normal data types are stored on the stack, and these are very fast in operations. So let's run this, and you can get still get the value 6, 6. You can also reference these values as well. So ampersand a points to, you can see the address of an i32 value. So run this, you get the same values. You can also do star b as well. So this is like fetching the value at that address. So we have seen this in the previous videos as well. Now we can declare a variable as a mutable using mute keyword. So by default in other languages every variable is a mutable. We can change its value simply, but in Rust we cannot change like that. By default all of the variables we declare are immutable. We need to explicitly define with the mute keyword that this variable is going to be changed in the program. Now I can say a plus is equals to 10. Now we can see we got an error. So let's run this. An assignment to borrowed a occurs here. So here we can see we have the value 6 and it is referencing by b. Now the a value is going to be added by 10. The problem is here b gets corrupted data, so that's why we are getting an error. If I go and comment out this one, this will be fine. So let's run this, and here we can see the output 16. So this is called readers writers problem, where somebody is writing, two or more members are writing and there are some readers. So here the b is reading the value of a while a is constantly changing. As long as the b scope is over, so that means after this assignment addition expression, as long as we don't use the b value, we are fine. If we use the b value, we will get an error because the value which was borrowed by b is being used later, so it gets some corrupted data. So it's like at this point b is supposed to be 6, but when I go and print this, it changed to 16. So this is called borrowing. So let's delete this one. Now you will be fine. Now let's talk about some string data types. So let's s is equals to string from let's say text69. So now s is a string data type, and this value is stored on the heap, and s contains the address, buffer and length, address, length and capacity. So we have talked this in the previous videos. S contains the address pointing to starting of this character, and the length contains the length of the string, and capacity contains the total amount of bytes it can store. Now I am going to push this one, push something, hello. Now we need to declare this as a mute. Let's run this, and we can see text69 hello. Now let me comment this one. Now let's go and say let s2 is equals to yes. Now we will get an error here. In normal programming languages, if we assign like this, normally the value will be copied into the s2 variable, and this s variable is also varied. But in Rust, this s2 is taking ownership of s, and s will no longer be varied. Now let's run this, and here it says value borrowed here after move. So we are using this value after it has moved, so that means s has been moved to s2. Now to resolve this one, what we can do is we can say ampersand s. Now ampersand is the reference to the string. Now s2 also points to this one, and whenever this s gets dropped off, then s2 is also no longer valid. Now here it is valid because s is valid. Now we can use something called drop function to drop the value. Now let's go and print the s2 value, and we will get an error because the s is invalid. Move out of s occurs here, so s is going to be dropped, and all the references pointing to that s will also be invalid, so that's why we got error. Now if I go and cut this and paste before the drop, and now we will get normal string, so that is valid. Okay, now what we can do is let s3 is equals to ampersand s. So we have two readers, s2 and s3 are reading the value at this s, that is text69. Okay, so that is fine. Now what I'm going to do is I am going to comment this one and comment this one. So I'm pushing some string here, value. Now let's go and print the s value. Now it will be fine. So we can see text69 hello. Now let's go and print the s2 and s3 value, and let's see if they are pointing to the correct string or not. So let's go and print this s2. Now here we got some error. So cannot borrow s as immutable because it is also borrowed as immutable by these s2 and s3 variables. So that means as long as there are valid readable or immutable references, we cannot do any operation. So we can do after this s2 because the scope has been completed. So we cannot do any operations, so because these readers will get corrupted data. So this means we can understand that in Rust we cannot have more than one mutable references, and we cannot have a mutable operation whenever there are two or more, whenever there is at least one readable reference in the scope. So in the scope we have s2 here, so as long as the s2 is valid, we cannot do any operations even though we have declared our s variable as a mutable. So that is the concept here. As long as someone borrowed your value and as long as they are in scope, you cannot change those values. So let's remove this one, and now we can see. Let's also declare a function. Let's see how we can pass this value into as a parameter. So we'll be covering the functions in the later videos. Just I'm going to define a function testing. It's gonna take an arg parameter name, and this is string. Now this function does not do anything, it just takes the string data type as a parameter. Now let's go and testing. Now let's pass this s value. Now as long as you pass it entire s, the whole value will be moved into the variable name. Then that means this s value is invalid. So let's remove this one and let's run this, and you can see value borrowed here after move, and where it has moved here, value moved here. So the s value has been moved from this s point to the name variable. Now unless I return name, unless I return a string data type to this one, s is equals to, then it will be fine. So it will be fine. So this is called consuming a value. So consuming means we are taking a, the function is taking a parameter and it is doing any operation and not returning anything. So it is like consuming this whole variable. Now you can pass the reference to this one. So we can pass ampersand string. Now I can go and print the length of this string, name.length. Let's run this. Now it will be fine. You can also pass the mutable references using ampersand mute. So if this function wants to change some value in our string, we can pass mutable reference ampersand mute. So you should also change this as ampersand mute. We are not changing anything, we are just running here. Of course we can also change here name.push string. So let's run this. Now we are passing this s as a mutable reference. Now this name variable can do the operations. Now we can see the string has been changed. You can also one more concept. Let's comment out. So let me rename this as reader1, reader2. Let writer1 is equals to, I am going to change this as a mutable reference. So the writer1 is asking mutable reference to this string so that he can write some values, and these readers are normal readers. Now I can access writer1. So the program will execute fine. Now let's copy this one, and now let's try to access reader1. So the same problem we get, because there are two immutable references in scope. So as long as there are any immutable references in scope, we cannot borrow this as mutable. So run this one, and here you can see we get the same error as previous. And the next topic we are going to discuss is the dangling references. So dangling is nothing but pointing to some random value or null value. Now let me show you an example. So here inside the function, whatever variable I create, it will be only for the function scope. Whenever I came across this closed brace, then the variable gets dropped. So let's say let my name is equals to, so let's say Lenovo. Now what I want to do is I am going to return a reference to this string. So return ampersand my name. Now you will get an error because we are returning the reference to the string that is getting dropped after this function call. So we get an error. So we need to specify some lifetime parameter. We will be discussing in the future videos. So for now, this is the dangling reference. You cannot pass a function variables reference in the return type, because those function variables here my name will get dropped after this function. you can say normal string and you can return normal string. So this is all about the Rust ownership, borrowing and references. If you understand this concept well, and everything will be so smooth. So the main key points are, whenever there is any single immutable reference in scope, we cannot have a mutable reference, and also we cannot have two mutable references. So let's say writer 2 is equals to ampersand mute yes, so we get an error. So think of this as like a notepad. So here we can see this is like a think of this as a shared Excel sheet. So this is very sensitive data, and this is being shared among 5 friends. So if our 5 friends are read-only permissions, then they can read whenever they want. If any one person got write access, then he will constantly write this data, and others get corrupted data. And also we cannot have 2 writers at the same time, because it will be getting the race condition and also corrupted data. So that's all about this Rust ownership, borrowing and references.